Hello, wonderful students. So I learned that if you're having any problems with it not marking complete, it's because the system would like for you to go in through your main class homepage. So today we're going to demonstrate that and make this help video. I truly appreciate all of you who use these videos to support your learning. They are optional, but I'm always here. Class recordings are always available as well. So we're done. We're doing unit 4. There is let me remove this due date. Well, I'll remove the due date later. Okay. We are done with unit 5. There is a progress learning practice, but I want to talk about the 505 because then we had 5 quizzes, we had our unit review, and then a test. Okay? And of course, my Chrome is not responding. No, we need to go to... All right, the addition rule. The math that you're doing and you're being asked to do this unit is very simply adding, subtracting, multiplying, and dividing either decimals or fractions. But the thinking you're being asked to do, amazing work, absolutely amazing work, it's making sense. So 99, that's fantastic. 99, anyway. A group of 15 students play different instruments. 6 play piano, 4 play violin, 5 play guitar. A student is chosen at random. What is the probability that the student chosen plays a violin or a piano? Okay, very simply, favorable outcomes. So if there's 15 students, 6 out of 15 play piano. That is the probability that you choose at random from that group that somebody will play the piano. 4 out of 15 play the violin. That's the probability they play the violin. And 5 out of 15. Okay, some of these can simplify, right? What's this simplify? 2/5. This one doesn't. This one simplifies to 1/3. We don't need to simplify in this case because we're going to add or subtract in the events. So we want that common denominator. We'll simplify at the very end. Whatever number, whatever variation you have, this is what you're doing. You're just saying, okay, 6 out of 15, 4 out of 15, 5 out of 15. We just set up the probabilities. This is not the same as a sample space. If we were to list the sample space, it would be piano, 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 violin, 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 guitar, 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 right? That's what we're going to pick from. Shake it up. What's the probability that the student chosen plays violin or, keyword or, we did talk about that if you were in class today, or violin. So now here we go. If we had our sample place, piano or violin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be the probability that the student plays piano or violin. These are mutually exclusive events. When you have mutually exclusive events, the probability of A or B is just equal to the probability of A plus the probability of B. That's it. So we counted looking at the sample space, but if we were used this notation, the probability of a piano is 6 out of 15. The probability of violin is 4 out of 15. Well, remember I said we're going to be using fractions with common denominators. There you go. 6/15 plus 4/15 is 10/15. Check. Using a sample space, using probability notation, using math, lots of different ways to think about it as long as we understand the situation. That simplifies, friends. What does that simplify to? 2/5? No, 2/3. Yeah, 2/3. Okay, let's scroll down and see how we did. 2/3. So no matter what variation you have, odds are question 1 will be mutually exclusive. Not always, but it's a good pattern you can think about. So you can think question 1, mutually exclusive. I just need to identify the correct probabilities and add them together. Possibly. Read your question. Think about it. Yep, they look like they are mutually exclusive. So yeah, that one is. So feel free to do that. Let's take a look at this one. Adam has 10 coins in his pocket, 2 nickels, 3 quarters, 2 dimes, 3 pennies. Adam chooses a coin at random. What is the probability he selects a nickel or a dime from his pocket? First, we have to think about what's happening here. Are these mutually exclusive? What that means now, definition-wise, is that they don't share anything in common. Nickel or dime, do they have any overlapping events? Is there any way that when we pick a nickel, we also pick a dime? Not in this situation, right? A nickel is completely independent from a dime. However, if we were to say we're going to pick 2 coins, what is the probability that it is greater than 5 or greater than 10 or 10 or greater, right? That the coin value is greater than 5 or greater than 10. Those have some overlapping probabilities. Those are not mutually exclusive, meaning the probability of one event happening isn't captured also in another event happening. We'll talk about that when we have it. So again, you would do 2 out of 10 for nickels and 2 out of 10 for dime. So 2 plus 2 is 4, which means he has a chance if he gets a nickel or a dime, that's 4 out of 10, which you can see right there. 2 nickels, 2 dimes out of 10 coins. So that's again adding their probabilities, which would simplify to 2/5. Check it. If you have any type of overlap, we got to think about it more carefully. Okay, these are all exclusive events for question 2, looks like so far. Let me take a look at question variation 3. Yeah, see how they can't both be a football and basketball card? So question 1 and question 2, mutually exclusive. Here we go. Let's keep going. Here we go, dice. All right, question 3 has a lot of overlap. What is the probability, the sum? We talked about that in today's class if you had the opportunity to attend or watch the recording. The number cubes is either 3 or an odd number. We had a list, right? We had this wonderful list. I don't know if I can pull it up in time. Oh, that's right. I moved it. Okay. We have a list of the sample space, but you can write them out. What is the sum? The sum of these, there's going to be 36, 2, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6, 6, 6. Uh-oh, I'm all messed up. Anyway, right? If you roll a 1 and a 1, a 1 and a 2, or a 2 and a 1, a 1, oh, maybe I did something wrong right here. To get a 4, you can do, a 2 and a 2, a 1 and a 3, or a 3 and a 1, and so forth, right? The pattern continues as you make the sample space. I'm going to go ahead and stop right here, and we'll talk about questions 3, 4, I believe 4, and 5. These are not mutually exclusive, and we can talk about that why and in a second. So again, I'm stopping with questions 1 and 2. We'll pick up 3, 4, and 5 in the next video.